Previously, we talked about how to use the difference of two squares formula to factor. In this video, we're going to look at two similar formulas. The first one is difference of two cubes. So instead of having two squares, we have two cubes. But for the two cubes, we have another formula, which is the sum of two cubes. So we can change subtraction to addition. But notice that for squares, we don't have sum of two squares. This only works for cubes. Now, these are the two formulas here. As you can see, they are more complicated than the difference of two squares formula. So if you remember difference of two squares, it's the product of a minus b times a plus b, or a plus b times a minus b. These two are called conjugates of each other. But so first, we're going to look at why these formulas are true. So we can verify these formulas by multiplying them. As we talked about it before, factoring problems are the opposite of multiplication problems. So let's look at how to multiply a binomial and a trinomial. So we distribute a to all three of them. So we have a times a squared, that's a to the third. A times ab, that's a squared b. And then a times b squared, that gives us ab squared. Now after we're done distributing a, we're going to distribute negative b. Remember, this minus sign goes with the b. So we distribute negative b to all three of them. So we have negative b times a squared. We're going to get negative a squared b. I switched b and a squared. ba squared, negative ba squared is equal to negative a squared b. Put them in alphabetic order. And then we do negative b times ab. That gives us negative ab squared. And then we do negative b times positive b squared. That gives us negative b to the third. Now we combine like terms. Notice a squared b and a squared b, these two are like terms, and they cancel each out. And ab squared minus ab squared, they also cancel out. And now, since these two are canceled out and these two are canceled out, we are only left with the difference of two cubes. So although originally we're multiplying two terms with three terms, after we simplify and combine like terms, and we only get two terms. And so this is a formula that we kind of have to memorize when we use it. So the difference, we will still have the difference, but the rest of them will be all positive. And notice it's how do we get the third? We must have a squared times a to give us a third. And similarly, we must have b squared times b to get b third. But we also have to have a term which is the product of a, b, the two bases. And for the sum, it's very similar. Notice the multiplication works in the same way. So first we distribute a. We're going to get a times a squared, a cubed. A times negative ab, that's negative a squared b. And a times b squared, it's positive ab squared. Now we distribute b to all three of them. That gives us a squared b minus ab squared and plus b to the third. And now we combine like terms, negative a squared b plus a squared b, ab squared minus ab squared. So we're left with a third plus b third. And so, of course, later on, so here, when you do factoring, you don't need to do this. Here I'm just showing you why a cubed minus b cubed is equal to that. So when we do multiplication, usually you're given two terms times three terms, or two terms times two terms. You have to multiply all of them out and combine like terms. So simplify your answer as much as possible. But when we do factoring, we have to reverse the process to go back to what we have. So we have to memorize this formula in order to do it. All right, so now let's see how we use these two formulas to do the factoring problems. So we can look at these two examples here. So first of all, and notice that this one, the first one, we have difference. And of course, notice that we have x to the third. It's not anything squared, so it cannot be difference of two squares. Although 64 is 8 squared, but x third is not anything squared. But notice that 64 is also 4 to the third. So first thing we're going to do is to rewrite it in the format of something cubed minus something cubed. And we know 64 is 4 cubed. And you can verify that by doing 4 times 4 times 4. That is 64. And x to the third, of course, is just x. And 1 can also be written as 1 to the third. So this problem does fit our formula, something to the third minus something to the third. So refresh our memories about the formulas. I'm going to write down the formula here for our reference. The formula, let me change AB to the base. So we have base 1 to the third minus base 2 to the third. So this is 4x will be our base 1 here. 1 will be our base 2. The formula says it's going to be base 1 minus base 2 times base 1 squared. Again, why is the squared? Because if you want to get third, b1 to the third, you must have b1 times b1 squared. But we also have an extra term, which is b1 times b2, the product of these two, and plus b2 squared. So this is the formula. We're going to apply the formula here. And keep in mind, in this case, our b1 is going to be 4x, the first base. Our second base, b2, is going to be 1. So in the formula, we're going to replace all the b1s with 4x. So let's look at the first parenthesis. We subtract the two bases, 4x minus 1. So b1 is 4x, b2 is 1. So replace that. And now do the other factor, b1 squared, which is 4x squared. When we do 4x squared, and we're going to work it out, 4 squared, 16. X squared is x squared. So this is one of the formula exponent rules we learned before. If the base has a product, we can raise each of them to the exponent. So 4 squared times x squared will give us 16x squared. Now, next part is plus b1 times b2. Notice that b1 is 4x, b2 is 1. So we have 4x times 1, which still gives us 4x. Now, plus the last part is b2 squared. b2 is 1, and 1 squared still gives us 1. And so that's the factoring we did, and that's the final answer. We got these two factors. So similarly, we can use the other formula. Notice this time we have plus, and we see like 2 cubes here. So possibly this could be written as something cubed plus something cubed. And we can verify it is, because 8 is 2 to the third, and 8 to the third is 8 to the third. And 125, we know it's 5 to the third, and b cubed is b cubed. And again, to help us to see how we apply the formula, I'm going to write down the formula here for our reference. So if we have addition, the sum of two cubes, the formula, first of all, the first factor we can get is b1 plus b2. And then we're going to have b1 squared minus b1 times b2 and plus b2 squared. And this minus here is trying to give us some of the negative so we can cancel some of the terms as we see previously. So if you have minus here, that will make some of the negative, which can cancel those positive ones. All right, now let's apply the formula. Again, in this case, our b1 first base is 2a. So that's our b1 here. b2, the second base is 5b. That's b2. Now apply the formula. We're not going to take the cube, but we're going to take only the base. So b1 plus b2, base 1 plus base 2. In this case, it's 2a. So b1 is 2a. Plus b2 is 5b. So that's the first one. Now, to get the second one, it's b1 squared. And again, b1 is 2a. So we have 2a squared. And work that out by using the formula. It's 2 squared, 4. A squared will be a squared. Now, next is minus b1 times b2. So b1 is 2a times b2 is 5b. and simplify that. That gives us 10ab. And then plus b2 squared. b2 is 5b, so we square 5b. That gives us positive 25b squared. And that's the final answer. If you want to make sure you did it right, you can check your answers by multiplying everything out. But you don't have to show this on your paper. You can do this on your scratch paper. After you multiply everything out, combine like terms, you should be able to go back to 64x cubed minus 1. And the same here. After you simplify this, you should be able to go back to that. So you can do the checking part on your scratch paper.